So I'm in the two real roots of this equation, so just the normal roots that we'd expect to get. This is a hidden quadratic. I'm going to let u equal x cubed. So u squared is x to the 6. Then I get 8u squared plus 7u minus 1 equals 0. Of course, you could factorize it in terms of x cubed if you prefer. Sometimes I do that. Now, if it's going to factorize, we'll have an 8u here and a u here. We'd have a 1 and a 1. This is the only way it's going to work. If I make this plus and this minus, it will check out. I'll get 8u minus u. Brilliant. So that means u is 1 over 8 or minus 1. Don't forget, this is x cubed. So now I take the cube root. Cube root of 1 over 8 is a half. I just cube root the 1, cube root the 8. There's no plus or minus. This is a cube root. So when you cube a negative, you get a negative. When you cube a positive, you get a positive. The same works in reverse with the cube root. So you don't get a plus or minus. And I'm going to get minus 1 as the cube root of minus 1. So yeah, those are my answers. Right, for B, we're asked to determine the coordinates of the stationary points of this curve. Looks somewhat familiar. The dy by dx will equal 56 x to the 6. I times by the 7 and reduce the power by 1. Then 4 times, when I'm dividing by 4, they just cancel. So I'll get 49x cubed minus 7. And this will equal 0 for stationary points. Okay, let's divide through by the common factor of 7, which takes us back to 8x to the 6 plus 7x cubed minus 1. You can probably see why I just did that, because we're back to here. X equals a half, or x equals minus 1. This time we're solving, we're finding the coordinates, so we need the y values as well. So you have to put them back in. So put a half back in. It's a little bit awkward, but you got your calculator. I'll do the first one. Actually, I'm going to do the minus 1. It's just a little bit simpler. Okay, just put brackets around the minus 1 to be careful. You might be able to spot that minus 1 to the 4 is just going to equal 1 actually, but I'm putting it in full. So I get 11 over 4 or 45 over 4. And then when I put in y equals minus a half, I get minus 171 over 64. So I'll just write these as coordinates. A half minus 171 over 64 and minus 1, 45 over 4. For each of these, we're asked to determine whether they're a maximum or minimum. So for this, I'm going to need my second derivative. Okay, so back to when it's not, haven't divided through by 7. It's a little bit awkward, but we're going to get 336 x to the 5 when I do 56 times 6. And then 3 times 49 is 147. And I get an x squared, the minus 7 becomes 0. Now let's sub in. So when x equals minus 1, second derivative, well, it's going to be minus 336 plus 147. You can work it out, it's minus 189, but we can see it's going to be less than 0, and that's going to make this a maximum. A maximum here. And x equals a half. Without even putting it in, we can see this is necessarily going to be positive because I've got a positive plus a positive. So this is going to be greater than 0. And it's okay to just do that. You should get 47.25 if you do it fully. So this one's a minimum.